All right, greetings. We are live from block 3 right now, working on lesson 9.5, solving quadratic equations using the quadratic formula. We've had a number of ways that we've solved quadratics up to this point. One of the ways was solving roots, right? So, for example, if we had something that was like x squared is equal to 25. Right? This is technically a quadratic, which we can solve, or even if it's x squared minus 25 is equal to 0, we could add 25 to both sides. We'd have x squared is equal to 25, and then we're going to take a root, right, of both sides. That's one way. Another one is we could solve by factoring. And solving with roots and solving by factoring are pretty quick, except for that there are limited ways to solve these. So for example, if we had x squared plus 5x plus 6 is equal to 0, right? We could factor it into two binomials, in this case x plus 2 and x plus 3 equal to 0, solving from there, and then we'll be good to go, okay? But what happens when we can't do that, right? We started solving by completing the square. Which was great because completing the square always works. And we had some success with it, except for that one of the things that we came to is that if we sometimes have a coefficient of that's not 1 for a, it becomes kind of a pain in the neck. And we're going to come across that today. So we're going to solve using the quadratic formula. Now, this is how the quadratic formula is derived. And I teach geometry, so I'm really big on proof, not just magically making up formulas, but showing you guys why particular formulas are going to work. And I think this is actually the first great algebraic proof, or one of the first great proofs that you're going to see, and one of the more important ones in high school math and a high school math curriculum. And I think this is critical. Seeing it derived, I used to require it being derived, no longer do that in Algebra 1. Sometimes we'll do this as an extra credit assignment because it's about a page worth of work, but have done this in the past, have done it for some higher level algebra classes that I've taught. So what we're going to do here is we first need to prepare to complete the square, because what we're going to solve this whole thing for is for x, right? Here, this is our standard form of our quadratic, right? Ax squared plus bx plus c, and we're going to get x by itself. So let's prepare to complete the square. Remember how we prepared to complete the square. First of all, we're going to have to clear out our c term. So let's get rid of c and get that over to the other side, okay? So what I have here then is ax squared plus bx is equal to negative c. Next step is that, remember, in order to complete the square, we have to have a coefficient of 1. So we have to get a equal to 1. In order to do that, we're going to have to divide both sides by a. So first of all, I'm going to factor out an a. So a is going to come outside. So if I have that outside, I have a x squared, right? My a is out. How do I factor an a out of bx? Well, consider this. If I have 1/2 a and multiply by a, that'll give me 1a. That'll give me 1, right? A times 1/2 a. A over 1 over a, my apologies, is going to factor out, right? So if I do the following, if I were to multiply this guy by b over a, x, right? If I were to redistribute this, I would have ax squared, and then a times b over ax is going to give me just bx. So that's how I'm going to get that term to look that way. And I still have negative c. And remember what I had to do. I had to get rid of a from that left side, and by get rid of it, I have to factor it to be a coefficient of 1. So how am I going to do that? Okay, I'm going to divide both sides by a, giving me x squared plus b over ax is equal to negative c over a. So just explaining what I did here, this is going to get me that coefficient where a is equal to 1. That's required for me to complete the square. Remember? So I go to my b term, I'm going to half it and square it. Half of b over a is b over 2a x. So b over 2a, half it and square it. All right. So what do I have now on the left side? Well, now left side I have x squared plus b over a x plus b over 2a squared, right? That's equal to negative c over a plus b over 2a times b over 2a, right, is going to give me b squared over 4a squared. Now consider this. Remember, wasn't concerned about getting this guy as the correct trinomial, because this right here, the b over 2a squared, is b squared over 4a squared, right? But what I really wanted to show here is what my binomial square will be. Excuse me. So I have an x plus, and remember this is the half it, b over 2a, and this is equal to this whole thing right here, which is negative c over a plus b squared over 4a squared. All right, next step is I need to combine some terms here. I've got two fractions. Let's add these fractions. In order to do that, I need to rewrite this guy. I'm going to multiply by 4, okay, top and bottom. In fact, I'm going to do that on this one up here so that I have common denominators. So right here, I'm sorry, I don't need just 4. I need 4a, right, because I have a 4a squared. So I need to multiply both top and bottom by 4a. So what that's going to give me over here is 4 times a times c, and this one's going to be 4 times a, or 4a squared. Now I have common denominators, and I can combine those. So what I'm going to have here is I have my binomial x plus b over 2a squared is equal to, my numerator is b squared minus 4ac all over 4a squared. So I'm going to rewrite that with the b squared first. And again, what am I going to do? You got to get rid of that square. So let's square root both sides. All right. So what do we have here? We have x plus b over 2a, because we squared that square, we square rooted that square. The numerator, it's going to be plus or minus, right? Square root of b squared minus 4ac over 4a squared. Now I can take a square root of this right here, right? What it's going to give me, x plus b over 2a, is going to be equal to plus or minus. The numerator is still stuck as b squared minus 4ac. And some people may look at them like, well, we can take a square root there. You can't, right? We have two separate terms. But the singular term, 4a squared, will come out as just 2 over 2a. And then let's get x by itself. Last step, I'm going to subtract a b over 2a from both sides, leaving me now with x equaling negative b over 2a plus or minus the square root of b squared minus 4ac all over 2 times a, which since these have common denominators, we can combine it, meaning that x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. The treat in all of this is that we now have the quadratic formula. This and we will learn it through song. It's a familiar song you may know. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In fact, I've got a classroom right now full of students that are really excited to live stream right now singing this song. You guys ready? Yeah. Awesome. Okay, ready? 1, 2, 3. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Done to the tune of Pop Goes the Weasel. Yes. The singing was terrible, unfortunately, but really, it was. I hate really saying A for effort because that's not really a thing for me. But they did try. They're now part of my streaming popularity, and forever this class will leave on in internet infamy. This is why this is such a great formula, because let's take this quadratic. 12x squared minus 4x minus 5 is equal to 0. That's going to make one of my clips here on Twitch. That little song. All right, we have 12x squared minus 4x minus 5. Now, maybe we could factor it. In fact, you can. You can actually factor that thing. Yeah, that's an adventure to factor it. We've been through factoring these problems. We could complete the square. Here's why completing the square kind of sucks, is because we're going to have to resolve this right here, right? That a equaling 12, we'd have to divide everything by 12 in order to start. And we're going to get a bunch of crazy fractions. Or we could use the quadratic formula. This is in the standard form, so we need to know what our coefficients a, b, and c are. So a here is equal to 12. B is equal to negative 4. And c is equal to negative 5. All right. Let's plug it in. Let's use it. X is equal to negative 4 plus or minus the square root of negative 4 squared minus 4 times 12 times negative 5 all over 2 times 12. There it is. Now we just get to evaluate. It's nothing too crazy. We can do this. X is equal to minus 4 is a positive 4 plus or minus the square root of negative 4 squared. Negative 4 times negative 4 is 16. Minus 4 times 12 is negative 48. Actually, I'm going to go back and do this. I'm going to go 4 times 5 times 12, right? Or negative 4 times negative 5, which is a positive 20, times 12 is going to be a positive 240, all over 2 times 12, which is 24, which means that I have 4 plus or minus rad 256 over 24. And for all of you guys who know these square numbers, rad 256, square root of 256 is 16. So there we go. What I have here then is two things. I have 4 plus 16 over 24, and I have 4 minus 16 over 24. I'm going to have two separate fractions I'm going to get, right? 4 plus 16 is 20 over 24. 4 minus 16 is negative 12 over 24, which if we reduce is going to be 5 sixths and negative 1/2. That is our answer. It's beautiful because it always works. Always works. Sometimes it kind of seems like overkill, right? Might be like it's like killing a spider with a shotgun. You know what I mean? Like it just is. But yeah, it's just way too much. Especially if we had this problem right here, x squared plus 5x plus 6. Could you use the quadratic formula? Yes. Should you? I don't know if you like using it that much, but for the rest of us who kind of look at that, we can instantly factor, right? X plus 2, x plus 3, right? The two factors of 6 that are going to have a sum of 5. So it always works. Kind of complicates things a little bit. But we can't always factor. When we can, go for it. When you can't, you got to complete the square or use the quadratic formula. Here's the problem. Negative 3x squared plus 2x plus 7. I would never complete the square here. Why? Because I'm really not in the mood often to divide every single coefficient by negative 3. I do not want to deal with negative 2/3 and negative 7/3 as I continue to move through, given that I'd have to half that term, half these fractions, and square these fractions. That looks kind of awful, all right? But quadratic formula, we get our A, we get our B, and our C. Our A is negative 3. Our B is 2. And our C is positive 7. Just keep singing it to yourself. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. I imagine on our next test, many students are going to be humming to themselves that sweet little tune. X is equal to negative 2 plus or minus the square root of 2 squared. Remember, whenever I replace and evaluate any expression, whenever I replace a letter variable with a numeric value, I put it in parentheses. It's, you know why I do this? It's the next issue. It's going to be negative 4 times negative 3 times positive 7. It's going to save me the issue with an error of signs. So sometimes people will screw up signs, positive times positive, negative times negative, that whole thing, or they'll drop a negative is the other error that we identify as math teachers. This is going to reduce you making those mistakes. Those are just procedural mistakes. They have no real impact on your lack of understanding, but they'll get you the wrong answer either way. And then we have 2 all over 2 times negative 3, 2 times A. And now we're just going to keep chugging right along, right? So we have negative 2 plus or minus 4 times negative 4 times negative 3 times positive 7 is going to be plus 84. 2 times negative 3 is negative 6. This is negative 2 plus or minus rad 88 over negative 6. We can keep going. In fact, right, negative 2 plus or minus the square root of 88, one of the factors of 88 is a square number, 4, right? 4 goes into 88 22 times. So if I take the square root of 4, it's 2, so it's 2 rad 22 all over negative 6. And then right here, I can reduce, because all of these things, all these coefficients can all be divided by 2. So 2 divided by 2 is 1, and then 6 divided by 2 is 3. So what we're left with here is negative 1 plus or minus rad 22 all divided by negative 3. And that's your answer. Two more issues to resolve today. Very quickly, we're going to go over this in our next class anyway. There's something that's called the discriminant. Remember, we can't divide, we cannot take a square root of a negative number. We can't take a square root of negative 22, for example, or even the square root of negative 25. So the discriminant is a portion of the quadratic formula. It's this part. It's everything that's inside of that radicand, b squared minus 4 times a times c. This is our discriminant. Here's how we utilize the discriminant. When it is greater than 0 Or in other words, if the result of it is positive, it means that there are two solutions. If b squared minus 4 times a times c is equal to 0, it means there is just one solution. It means it has one root that will be on the x-axis, right? It's this idea. We remember what a quadratic makes. It makes a parabola, right? So here's two solutions, right? It intersects here and here. Or if I have one solution, right? I have one place that it intersects on the x-axis. What's our other alternative? Well, there's no real solution. So negative b squared minus 4ac, when that's negative or less than 0, it means there are no real solutions. There's no roots or intersections of the x-axis. There are no x-intercepts. All right, so this is what I'm getting at, guys. Let's take this one. Y is equal to negative x squared minus, plus x minus 6. This problem, I'm already going to tell you, is going to have a negative discriminant. If that's the case, there's no real solution. And here's what I mean. A is equal to negative 1, B is equal to 1, and C is equal to negative 6. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Which of course here is going to be negative 1 plus or minus the square root of 1 squared is 1. Negative 4 times negative 1 times negative 6 is a negative times a negative times a negative, which is negative. 4 times 1 times 6 is 24 over negative 2. Here's my issue. It's negative 1 plus or minus rad negative 23 over negative 2. Guys, this is our discriminant right here. Negative 23. Can we take a square root of a negative? No. So this guy, means there is no real solution. Anytime we get a negative inside of that radical, in the radicand, that negative radical means we have no real solution. And that's all we got for today. Good luck with the quadratic formula. Sing the song. Do you get a note card for your next test? Absolutely not, because you're going to sing in your heart and write down that quadratic formula probably as you start the test. Good luck.